Good morning to everyone. And that was Fleetwood Mac. And what was the title, Ernie? Dreams. I think we'll probably go with Don't Stop for the end so that we can remind you that even though the class is stopping in terms of lecture today, so those of you who've been watching with us on the Palomar 3C Media Solutions Network, this will be our last broadcast. Oh, I guess tomorrow we'll still do it tomorrow. They will broadcast that, I believe. So we have one more day, but this is our last regular lecture. Tomorrow will be a tutorial. And so we're bringing things to a close. We've been, I will say this cautiously, having fun graphing. Some more fun than others. And we've been looking at the two-intercept form. We've been looking at how to use slope to get another point once we get the intercept. And we've been talking about how to change equations. The one thing that came up yesterday that I thought we had resolved, but I think we need to spend more time today doing, is horizontal versus a vertical line. Okay, what have we got? Okay, Ernie's on his way. But we have to focus on special cases, and I was I was talking with Marisol yesterday as we were working some problems, and there's a group of problems that all go through the origin. The graphs all go through the origin, and I want to look at that today because that seemed to cause some trouble. But what I'm starting to feel better about after, this is what, third day we've been doing this, that maybe it's starting to fit. Without quite the angst and quite the concerns. And the goal I had was just keep doing the problems until it gets boring. And you can do it without hitting hang-ups. And you'll find that it doesn't take much to throw you off balance. One little problem, one little change, and you go, oops, now what do I do? And that means we haven't done enough. I mentioned to you that we will tomorrow devote our time totally to a review with the idea of getting ready for the final. And that I will have the first hour we'll broadcast, and the second hour we're going to make a 2-hour session out of it. The second hour I have in mind going ahead and actually doing problems in small groups and just more of a classic tutorial like we had in Math 10. And what I had in mind is maybe giving a problem from each area, see how you can do, just to shake some of the cobwebs loose. Now that assumes people are here. It's very difficult to do that second hour in small groups with 2 or 3 people. One person does not become a group. So sort of like y'all come, to use Sarah's vernacular out of Texas. Expect you to be here, and we'll try to do that. If it's just 1 or 2, we'll do our tutorial on the broadcast and probably open a short period of questions and call it a day. I'm making it available. Expect you to be here and participating. Thank you. I want that in signature on the dotted line, notarized by the appropriate figures with penalties there too. If you're not here, you will have to do penance for 40 days and 40 nights doing algebra problems. You love it, yeah, huh? No sincerity. The particular problems that, 2 types that I want to focus on right now before I open up to questions. And the first is a group of lines going through the origin. They all have one basic form. So Ernie, I'm going to go to the board on this, and we will look at a Cartesian coordinate system and a reminder that you need a blue book for the final. The final will be on Wednesday. I believe it is. I answered that question for Bomaro. And that'll be at 10 a.m., I believe we said just then, wasn't it? Or, yes? I thought it was Wednesday. I will check. Maybe it's Monday. Okay, let me check. I was trying to remember something we just talked about. I will check. My calendar is Monday, so 10 a.m., the first day. Okay, so 10 a.m. My apologies. Now to the board with a coordinate system. So we're going to need to draw a coordinate system, I need to locate a straight edge, so I'll disappear momentarily, come back, and I have vertical, horizontal axis. This is your x, this is your y. Now, I want you to watch something with this straight edge, and I'll just get over here. That is a line going through the origin. Okay? Another line going through the origin. Another line going through the origin. Now, this particular line has a positive slope, but another line going through the origin, positive slope. What is the intercept on the vertical axis for all those lines? 0. These all have the form of y equals mx, technically plus 0. Now you see it more often simply as a statement, y equals, say, 2x. Or you might have something a little more complicated. You might have a y equals 1/2 x. Or you might have it a little more complicated, y equals negative 1/3 x. But they're all characterized by what? Plus 0, plus 0, plus 0. We don't write the plus 0, but it's understood. And so all these lines are going to go through the origin. Now when you try to do the two-intercept form, you get very disconcerted because you set the table up and you say, well, I'm going to go ahead and I'm going to get a table and I'm going to take an x and I'm going to take a y and I let x equal 0 and sure enough y is 0 and you say, well, I can only get one intercept. How do I get the second point? And that's where the wrinkle comes in. Because how would you get a second point out of any of these? Pick any x you want. Y is just equal to it. That is to the right side. So if I take the first one and I said x was 3, then 2 times 3 is 6. So that's for this particular equation. And I have my 2 points. And you plot them. That's straightforward. Now, if I look at this down here, whatever I use for x, I'd like to avoid a fraction. So what are my choices that I could use for x here? And not have a fraction when I'm done. Well, a 3, a 6, a 9, a 12, a 15, any multiple of 3. I would avoid a 4 or a 5 because I get fractions. It's not that those points are bad, but I'd like to plot an ordered pair that has integers in it. Now, as you do this, how many points do you need? 2 minimally, and your text is asking you to get a third one, correct? And it's just a checkpoint. It was interesting that if you look at your ordered pairs, and Marisol and I just looked at one before the lecture started, in which I was trying to show where the third ordered pair would be. And it was interesting because her graph looked neat, but she had a little wider space on one of her intervals than she did in another one. So they weren't uniform. So it was a little bit of a space, a little wider space, a little bit of a space, and so they were just off enough that when we went to the third point, it didn't come on the line. But technically it should. So the question is, I would encourage you to use not only a straight edge, but maybe get a ruler, small one of those 6 inches or something that's easy to carry, and just go 1/4 inches to mark off your spacing, or a 1/2 inch, something like that. So if you're going to use the third point, my caution is, if it's not on your line, it may be that your scale was not the same. Horizontal and vertical, left and right, up and down. Now, if you want to avoid being frustrated, go with 2 points, get your line, and hope you're right. And this will avoid some frustration. I'm not going to demand that you get me the third point to check on the exam. I just want you to be able to get 2 points and draw me the line. And I'm not going to, at this point, it was very clear after yesterday that I don't want to specify what technique you use. So if you decide your 2 intercepts, you're in love with it, it's the only way you ever intend to graph, You know you have a little bit of a problem here. But if you decide that you want to go slope-intercept, that's your choice. If you just want to find 2 points, the only request I will make, I don't want fractions in your ordered pairs. So you have at least 3 techniques that you can use. Divine inspiration, and just throwing a line on the paper that happens to be right without points plotted will not get you full credit. Robert. No, you cannot get extra credit for doing more than 3. As much as you might want the extra credit, it's not a penny a point for each extra one. Okay? Lomaro. I think I know the question you have. Not, okay, this is one class of problems, correct? It's y equals mx. So technically I should probably write up here, y equals m times x. And just a reminder, what does m represent? It's the coefficient of x, and that coefficient of x is called the, starts with an S, the slope. Ski slope, how steep it is. Think snow. And you'll tell me m is for snow. I want the slope. Okay, what's the other form that we have? Well, this would be technically the slope-intercept form, but what is the other form for an equation of the line? I called it standard form. How is an equation in standard form? Okay, I've asked a question that I think you know the answer to, but you don't realize what I'm asking. Okay, sliding over. If this were our equation, no, not midpoint, not line segment, nope. This is just a standard form equation. You have the variables on the left side. It's a linear equation in 2 variables, first degree. But it is different from what we just looked at because you have x and y on the same side. Now that form lends itself to intercept. So reviewing the technique, if I just make again the xy table, then I like to do these 2 ordered pairs and use that as my template. That is, I'm going to let x equals 0 solve for y, let y equals 0 solve for x. This caused us some trouble, bothered me yesterday and the day before, because if I let x equals 0, I just cover that up and 4y equals 12, and I was hoping you'd just tell me y was 3 and be done with it. Is that better today? Not if it is. Most of you are nodding. Okay. Now, if y equals 0, 3x equals 12, x is 4, and 2 intercepts, and you're done. Now, note, this works very nicely if the number here is a multiple of both 3 and 4. Now, we had the wrinkle yesterday that Ernie noted. Got to keep you awake there, Ernie. 3x, I'll just come over here, 3x plus 4y equaled 7. And of course the idea there was it's a trivial one that I didn't see, that x in 1 and y in 1, and you're there. So if you look at the ordered pair, 1, 1, 3 plus 4 is 7. Now, it's not good for the 2 intercept form. Because if I let y equals 0, x is 7/3. I don't want that. If I let x equal 0, y is 7/4. I don't want that. I want integers, no fractions, because I want to graph my points as accurately as I can. So this is where I suggested, and we seem to have some success with this yesterday. I'm doing this hoping that you're feeling as good as you may have felt yesterday, may have noticed. But we had a little wrinkle here that I have to be careful of. I want y by itself, and we said you divide by 4. And I learned something yesterday from you. When I divide by 4, I'm going to do it differently than I've been doing it. Therefore, we don't cross-cancel one of them and end up with a constant over here, Sandra, that we don't want. Okay, so y is negative 3 over 4 times x plus this 1 3/4, if you like, but I don't like having to plot a point like that. I have a 1, 1. So how do I get my next point knowing I had x at 1 and y at 1? The slope is negative 3 over 4. I always write the bottom number positive. So I'm always going to go to the right. So this says run to the right 4. Okay, so I was at 1. If I go 4 to the right, I'll be at 5 for x. What has to happen? Yes, sounds very English. What happens today? What happens to y as x runs along 4 units to the right? Y decreases 3 units. It's like the temperature dropped. And by the way, for you watching, down in Southern California, we will be dropping 20 degrees today. We were at 98, so we dropped 20 to 78. That's a minus 20. So if you were at 1 degree and you dropped 3, you're at negative 2. Very good. And it's because the temperature dropped. You have it. That's why. And now I have my 2 points. If you wanted another, add 4 to 5, you get 9. Drop this by another 3, and you're at negative 5. Marisol. Yes? No, because I want y by itself. Now, what Marisol is mixing, I will come back to a different problem, because I know what you're trying to get at, and let me rewrite the problem for you. So let's say it was 1/3 x plus 4y. So 1/3 x plus 4 times y is equal to 7. Just a small variation, right? However, what don't we like about that problem? The fraction. You know, I've spent an entire semester, last semester, trying to get you to where you really liked fractions. And I feel like I've betrayed the whole cause by now saying, get rid of the fractions. Fractions are good, but not here. Oh, never liked them anyway. Before I do any subtraction, I just want to get rid of that pesky denominator. Pesky denominators. So what will I do to get rid of the pesky denominator? Multiply everything by 3. Now, I'm going to rewrite this so I don't have to be talking about the distributive property. But in essence, I was using the distributive property. So I multiplied everything by 3. Now, the nice part is this is 3 over 1, correct? So the 3 times its reciprocal goes to the identity, 1. Hence, this becomes an x. Now, this doesn't look so hot because I've got 12y, and that's equal to 21. So I don't like 12 all that. Well, if I wanted to get y by itself, that's a different story. But my point is, now try your 2-intercept form. When y is 0, I love it. X is 21. But what I don't like about 21, it's so big. Okay, I mean, you thinking going 1, 2, 3, 4, and then you go 1, 2, 3, 4. Nobody said go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 21 to graph. So let's see if we could do something better. So let's say y was 2, 24, minus 3 is 21. Okay, I said I'm going to just choose, and this is the hard part, and there's no, you know, Kim's asking, how did I get that number? Doing enough math for more years than you'd like to count, it comes sort of intuitively. But I'm looking and saying, well, 24 is close to 21. And 2 times 12 is 24. And if this were minus 3, 24 and negative 3 is 21. So I said, well, let's let y equal 2. That gives me 24. So x plus 24 equals 21. Well, to get close to 21, so y equals 2, that got me close to 21 at 24, and if x is minus 3, now that is a heck of a lot better than 0, 21. It's on my page. You make that little coordinate system, and you'd like to stay in the page. Now, there are other values we could do, correct? So, for example, if I made this just a 1, then this would be a 9. So if this is a 1 and this is a 9, that's pretty nice. 9 1's a nice number to have. But notice it isn't as easy as some of the others. So there are times when you're stressed enough, you won't see anything. You'll see the 0, 21 maybe. 0 for here. Actually, the ordered pair would be 21, 0. If x is 21 and y is 0, that'll work. So what's an alternative? Solve for y. We're going to get the slope. So if I solve for y, and I'm going to do it here. You could have done it here also, correct? You can solve for y either place. I'll just solve down here. 12y is equal to negative x. Boy, did I just blow that in terms of trying to get that crowded together. That looks like something I don't want to even recognize. 12y is equal to, then I have the minus x and plus 21, correct? Then divide by 12. And when I do that, this, I'm going to write it down here now, becomes minus 1 over 12 times x plus 21 over 12. Now that's not a very nice looking equation, but the slope is minus 1 over 12. So if I got this at negative 3, it says add 12, that gives me 9, and you go down what? 1 from 2, which gives you the 1. So this point becomes this looking at the slope of negative 1/12. That was my slope. So again, I added 12 for the run. Negative 3 and 12 went to 9. The rise was negative 1, so I go negative 1 from 2, and I'm at 1. Make sense? Okay, now these are two different ways of looking at a problem. One is with slope-intercept, and the other just as a standard form. So standard form is you have x and y on the same side. Slope-intercept means you have y by itself on one side. Either technique works. Now, Ernie, I'm going to just leave this on the board here, and I'm going to disappear off this after you make the camera change because I want to be able to go to the sideboard for more problems. Bomaro, before I leave this set. Okay? Before I answer questions, I'd like to cover one more type of problem as a general presentation and then answer questions related to problems you've been working on. So, Ernie, are you free to the point where I've got the camera moving? Okay, the camera is moving. And while that's moving, Marisol, you have a question? The question is, on the 1 3/4, that is the intercept in the vertical axis, and that stays there no matter what. Okay? Does that answer your question? Okay. Now, to the sideboard whenever you're ready, Ernie. We have an x and a y axis, and who is responsible for this? Mathematician. Descartes, yes. Cartesius. Okay. Now, Cartesius, Descartes, 1637 roughly. Just about 30 years before Newton invents the calculus. And the argument is that I have a horizontal and a vertical axis. Now, if I have these two equations, y equals, say, 4, and I'll compare that to x equals 3. Now these are two equations. Let me show you what the real equation is. This one corresponds to 0x plus y equals 4. This was x plus 0y equals 3. I didn't do that much when I talked about horizontal and vertical lines. Okay? Now, in that first one, the coefficient of x is 0, correct? That means that slope is 0. No matter what run you have, the change in the vertical is 0. No rise, no matter what the run. So if you have this equation and the slope is 0, it's like you aren't going downhill or uphill. You're just flat line. If you look at ordered pairs, I don't care what you put in here for x, what's going to be true about y? 4. Y has to be 4. So if you look at this and you think, okay, I'm going to make a t-table. I let x be 4. Y is 4. I let x be 10. Y is 4. Let x be 1,000,000. Y is 4. So how do I draw that? Well, if x is 0 and y is 4, then that means it's going through that point and it will be a horizontal line. This is the line y equals 4. Now you can try to think your way through it, but you have to remember that if you have y equals some constant, it is a horizontal line. End of story. Now this next one's not quite as easy for me to explain. Here I was able to say the slope is going to be 0 because the coefficient of x is 0. In this one, if I thought of solving for y and then dividing by 0, you can't divide by 0, okay? But that would say the rise is infinitely large. There is no run. This is a vertical line. So if I tell you that x is equal to 3, it simply says if I come over 3 units to the right, no matter what y is, x is 3. So I can think of y being 40. X is 3. Y is 5. X is 3. So you're going to go to 3 something. Well, no matter what the something is, it's going to be in this vertical line. And this becomes then the line for the equation x equals 3. We say that the slope of this is undefined. That's important for you to understand. A vertical line, the slope becomes undefined. Now, when we talk about slope, okay, and I look at this as the definition for slope. Remember, I had 2 points, P1 and P2. So I look at the change in the vertical over the change in the horizontal. This became the rise. This became the run. Now, as I look at lines going through this intercept here for a moment, do you understand that as I go along, the larger the slope is, the shorter the run is? So as I bring this line and rotate it, the run is getting smaller and smaller as I go from points. And the closer I get to the vertical, the run is going to 0 as the vertical gets higher and higher from point to point. So this run goes to 0. And as that happens, the rise gets infinitely large. Okay? And so we say, since this is going to 0, and you can't divide by 0, the slope is undefined. So for a vertical line, the slope is undefined. But for a horizontal line, the slope is 0. Now again, you don't need to know that, but you need to know that if I tell you x is equal to 3, that you're going to have a vertical line through x at 3. If I say x is 5, a vertical line through 5 on the x-axis. X by itself will be a vertical line. Y by itself will be a horizontal line, and you just have to remember that or think your way through it. Now, Bolmaro, you had a question. Good. I anticipated your question. And this means that we have 3 different kinds of lines to think about, 3 separate scenarios. I classified this as one grouping. Horizontal vertical lines. Then the one we started with Marisol's question, the lines going through the origin. Now, Ernie, could you bring camera 1 to that coordinate system on the left in the front, please? Bring that up for me again, the coordinate system there. If I look at all the possible lines that could go through this origin, and I talked about doing this by just running this straight edge and saying, here is one of those lines, here's another line. This is referred to as a pencil of lines that I could draw through the origin. And they will all have the equation y equals something times x. So when I had this one, let's go back to this one, y equals negative 1/3 x, it's going through the origin, but what is its slope? Negative. So what does that tell you about the choice you could make? Is it a line like this or a line like this? You agree with Michael? I was talking about y equals negative 1/3 x, and he's saying it has to be a line like this because it's going downhill with a negative slope. Okay? There's a nice line that I want to draw that becomes the heart of intermediate algebra. It becomes a very important line in statistics. It is the simplest of all lines to draw. The line is y equals x. What's the coefficient of x understood? The coefficient of x. An understood 1, agreed? It's one that we don't typically write. It's the unseen one, the noceums of mathematics. The exponent that's 1 when you don't see it. The coefficient that's 1 when you don't see it. The denominator that's 1 when you don't write it. All these ones that are there that we don't acknowledge. But its slope is 1. And that is, I'm going to be careful here and hope that I manage to do this the way I want. Let's see. Okay, if I did this square well, drew it well, we have a unit square, correct? And this line will go through the origin, and it says its slope is 1/1. That's 2 ones you don't see. The 1 which was the coefficient, but under the 1 is another 1. It's important to see it as 1/1 times x because the run is 1, the rise is 1. Go over 1, up 1, next point. Yes? Yes, that's where I was going to. Michael asks, is that like a 45-degree angle? And indeed it is. This is, remember the 90-degree angle here between the 2 axes. This is just half that at a 45-degree angle. And this is called the axis of symmetry for problems that we are going to do in intermediate algebra. And we've touched on that. Let me touch a little bit further. We talked about E, correct? No, not E for energy, although with Earth Day, that seems like an appropriate choice. But E for PERT, P-E to the RT, E to the X, continuous compounded interest. Okay, and so if I look at E to the X, now notice this was y equals x, we've had this key we've looked at, and if I said y equals e to the x, tweak, thank you. Note I didn't say tweet, I said tweak as opposed to tweet, as with Twitter. But at any rate, this is not a line. This is called exponential growth. And here is this curve that you get for y equals e to the x. And that's the way populations grow. Now, a question from Sandra.
How did you get that curve? Wouldn't you just be able to do it the other way?
I could have plotted points. And you say, couldn't I have just as well gotten it the other way? As x gets larger, y gets larger and much faster. So if x is 1, you get e, which is 2.7 roughly. If x is 2, we get e squared, which is a little bit under 9. Yes. You put x at 1 and get e to the first, which is 2.718. Then if x is 2, you get e squared, which is 2.7 times 2.7, which is up around 7 something. And then if x is 3, you get 2.7 times 2.7 times 2.7, which is getting above 20. This grows much faster than going here. The rise is not constant. It gets bigger and bigger as your x's get larger. And so we call that the exponential curve. Now here's what I wanted to point out. Well, this is the line y equals x, and we talked about this in our problems for simple interest. That was one of the sections we struggled on doing. Now, if I considered this an axis of symmetry, then I'm going to get this curve. And if you folded the board along this, y equals x, these two curves match up. And this curve here is called the natural log of x. It's reversing all the ordered pairs. So my point is, we worked with e to the x, and e to the x as an equation, now y equals e to the x, is a curve, and that's the way the world's population grows. When you say things are going exponentially, that's what we mean. This is called a logarithm. It is simply reversing all those ordered pairs, and we relate it to y equals x. So this equation, y equals x, is terribly important. And I use this equation, y equals x, in statistics to talk about whether a distribution of data, like your grade distributions, fit a bell-shaped curve. And we come back and look at this y equals x there. So that very simple equation is one that I want you to feel very comfortable about. This I'm not too concerned, but let me give you a very classic problem, Sandra, to relate to this idea of exponential growth. There's a problem called Sessa's reward. And it's sort of a simplistic trap in the sense I say, I've got a job for you to do this month. I want you to do it each day for me. So maybe I have some papers I want you to grade every day, and here's my agreement with you. The first day I want to give you $1. That's all you get. It's going to take you all day, but I'll give you $1. The second day I'll give you $2. But you have to work all day again. The next day I'll double it and go to $4. Again, you have to work 8 hours. Then the next day I'll give you $8. Would you be willing to take that job and work for me for a month? Well, some of you are saying, yes, you would, and others, even Ernie's going, oh, yeah. Now, why is it such a good job if all I'm giving you is $1 the first day? Well, I keep doubling it, so what? You only get $2 the next day. Big deal. Ah. By the way, this is a way you can win at craps also. Double your bet until you win. Now, the problem is, you may go broke first. So you have to have a whole lot of money to do this, or the house has to agree not to cut off your bets. So let me go to the sideboard again with that idea in mind. Again, I look at a set of ordered pairs, and powers of 2 are a lot nicer than powers of e. Okay. So I have x and y. And my equation that we're just talking about is 2 to the x. So when x was 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. When x is 4, y is 16. When x is 5, y goes to 32. When x is 6, y goes to 64. Now notice the difference between these, the run becomes what? 1 each time. But what happens to the rise as I go along? It goes from 2, then it goes to 4, then it goes to 8, then it goes to 16. It's going to 64, and this is called exponential growth. So at the 30th day, it's 2 to the 30th power that I'm getting. Okay, now 2 to the 5th is 32. 2 to the 10th is 1,024. So this is 1,024. That's to the 10th power cubed. So that's roughly 10 to the 3rd, which is 10 to the 9th, which you know is what? 1 followed by 1, 2, 3, 1, 2, 3, 1, 2, 3. So how about thousands, millions, billions? You get $1 billion on that last day. That's just for one day for the month. That's the 30th day. But you turned it down because you weren't going to work for any old $1. Okay? Pardon? No, no, you didn't jump on it, so I'm sorry. You didn't go ahead and jump on it soon enough. No. Oh, yeah, that's just one day. So you donate the other to charity to pay for the taxes. See, the argument is if you're betting and you lost all the previous bets, if you lost all your previous bets and in that last one you won, it would wipe out all your losses plus give you a very big win. The problem is most casinos don't allow you to bet this much to cover your bets if you lost all the other tosses. This is where you, well, the house wins. The house will always win. They don't want you to win. They want you to win occasionally and keep playing. Because if you keep playing, you will lose. Okay? Well, take the stat course. We talk about that in there, called probability. Okay. Now, in this, my point being y equals x is a very important part of this. This was an intermediate algebra problem. It was called Sess's reward because most people would refuse to work for $1 a day. Or it's usually done a penny a day to make it more ridiculous. You work for me, and my day is 12 hours. I'm going to give you a penny the first day. That's it. Next day, I'll double it and give you 2 cents. So within the first 5 days, you aren't even up to $1 yet. You're saying, hey, this is no good. I'm not going to work this. Of course, the last day, divide this by 100. Now you're at 10 million. Okay, so you got 10 million the last day. I cheated you a little bit. Okay? Starting with a penny the first day. And just keep going along. Now, technically, this is the 31st day because the first day you have 1 penny, and then we go to the second day is where you get $2. Otherwise, I start 1 the first day, and then you go to the next day, and so on. Yes? Exactly. What Marisol's saying, a really dirty trick to play in somebody who doesn't know mathematics, and that was why it was such a classic problem. Everybody would refuse to do this. And of course, the other form of this is you have a chessboard and you put 1 grain of wheat in the first square. Then you put 2 grains of wheat in the second square. Would you be able to continue that and get all the wheat on the chessboard? And the answer is no. Because by the time you get your last square, you can't have room for it. You need a warehouse. Okay, that's all I wanted to say. Now, do you have questions on your homework? James, is that a yes? Okay, which one do you want to look at? And could you tell me what number 38 is from the book? Minus 1 or plus 1? So minus 5x minus 1? Okay. What's the beautiful part of this? It's already in slope-intercept, right? But you can't see negative 5. You have to see what? The one that's not there. The one that's not there is under the negative 5, and that is what you have to see. And what does this give you? Always the y-intercept. So if we're going to use that one in this form, and you have a choice of changing it, but if I'm going to use it in this form, I make my coordinate system, and I say this is 1, and so that's where it's going to cut the vertical axis, because this constant is always where the line crosses the vertical axis, hence the y-axis, hence the y-intercept. Now, how do I get to another point? This is playing pirates, not the Somalia kind. But this was the pirates of Robert Louis Stevenson, Treasure Island. I give you, here's the tree you start. Now I'm giving you directions to get to the magic box where the treasure is. It says do what? Go over 1, down 5. So go over 1. Make sure my scale is appropriate. And then 1, 2, 3, 4. Bad choice, Curl. What? Midget tattoo? Okay, this is a slope which says the run is 1, the rise is -5. So if I may help doing it easier, because you saw this with less trouble, so let me go ahead and say that x was 0, y was -1, correct? Now, this says the run is 1. So what is 0 plus 1? 1. The rise is -5. So if I had a -1 and went down 5 more, you'd be at -6. -1, -5, right? Well, that's what I was trying to say here. Go over 1, down what? Then I'm going to go down, way down. Way down here at the bottom is supposed to be -6. We'll just say it is. And that means then that you have a line like this, and there's my graph.
But what about 3 if you were doing 3? Because I got that one.
Okay, we can do 3. We can do 3.
So when I tried to get the third one, I got 2 with -11, and it didn't work that way.
Well, let's see. 2, -11. It will. I just don't have room. You have to be very careful. Remember I said you have to be very careful of your scales, because if your scales are not even, that's the problem I have with Maricel's, the point wasn't quite on the line. So why frustrate yourself? Don't do a third point on the test. Give me 2 and be happy. Now, I ran out of room, so could I go back the other way? Well, we said that reverse the run by 1, and this reverses by 5, and add 5 that, you're at -1. If I went the other direction, it'd be -1, and add 5 to that, I'd be at what? 4. So that says if I go over -1, depending on how well I did this, this should be meeting this over here at what? At 4. Let's see how close I am. Okay, there's my unit. 1, 2, 3, 4. I wasn't right on target. I missed it by a ½ inch. Now, unless you're using some very careful tools, and remember, my problem is I couldn't figure out where -6 was here. So the problem I had is in terms of where the line meets, if this was supposed to be just that much different, okay, just that much, then this should have been meeting where? Right there. Well, I was darn close. But the point is, it's just my sloppiness, not these ordered pairs. If I make a big dot, then that solves a lot of things. But a dot's supposed to be what? A dot, not a blob. So if you want to cover your errors, make big dots. Yes, Jessica.
You know the y-intercept, we only use it for one?
1 point.
Yeah, only one that's
The y-intercept only gives you 1 point, and you need 2.
Okay, but you can't reuse the y-intercept again for
No, you can't use the y-intercept to get another point because it's the point you were.
Okay, then that's what I'll
I mean, you can't with 1 point get the same point and draw the line. Glad you got the point. Any other questions on homework? And James, did that answer your question? Okay. Now, you didn't sound very enthusiastic. Yeah. I know. Hint, watch the tape. The VHS tape. There were quite a few of you weren't here the last couple of days. Spend some time in the library watching the tape. Not for penance, but because it might be nice to see that presentation and feel stronger about it. This is a very, very important section. I've been spending a lot more time than I can justify, but I feel passionate about you being able to graph a line. Okay, other questions? Somebody else had a question. Oh, I'd be delighted to do a decimal. I've talked about this before, but let's talk about it one more time. What is the problem, Kim? Would you give me the problem? 1.2x. Okay, now I made the comment, of all the things I've done in graphing, you'll never see an example like this that you have to graph. Now you will see these problems coming out of mixture problems when you're solving word problems. But you solve them not as graphs. You solve them in other ways. So when I get something like this in general, I don't like the decimals either. And again, I feel guilty because I tried for a whole semester to get you to really embrace fractions and decimals. And now I'm recanting like Galileo. I'm going to multiply everything by 10. Because if I multiply by 10 to the first, the decimal goes one place to the right, and if it goes at the end, I can let it drop off. Like Columbus dropping off the edge of the earth if you go, okay? 12x plus what? Multiplying everything by 10. 5y equals, you've got to remember, what you did to the left, you do to the right, 6-0. Now it's not so bad. Because now what can you do? Well, it was not as obvious as before, I suspect. Do you see the two intercepts just sitting there wanting to be found? I mean, they're begging to be found, crying to be found. Nothing with fractions. I don't want fractions. If x is 0, I get 1, and if y is 0, I get the other. So when x is 0, do you like what you see? What do you get when x is 0? A 12. When y is 0, what do you get? A 5. It doesn't get any sweeter. Well, that's the two intercepts. You still have to graph it. But notice that wasn't so obvious up here. It would work, but this is so much nicer. So you change your original equation so that there are no decimal points that you see. Michael. Okay, yes, you can change fractions to decimals and then multiply by a power of 10 to clear the decimal points. It will work. Thank you. But it's twice as much work as you need to do. But your choice. Now, if you enjoy working with numbers, sometimes it's a neat challenge just to do it, to have fun. But don't take the extra time on a test to have your fun. On the test, do it fast. Don't. God, the phrase that came to my mind comes from a baseball movie. Don't lollygag. Well, if you go too fast, then you make some DAEs. But it's a balance between too slow and too fast. Get in the groove. 3 minutes a problem. Okay, speaking of the groove, we're down to less than 3 minutes left for this part of the broadcast. I had asked you, if you finished this set of problems once, do it again. If you finished it twice, you would do it again. Now, homework tonight is go back, look at the first 3 tests. I want you to look at the first 3 exams. And I want you to look at the problems and make a mental note, what do I need to ask tomorrow? Because I want you to bring those tests in, and we're going to look at the problems, and we're going to spend 10, 15 minutes in each test and ask, what is it I'm having trouble with? How do I do it? So with that, Ernie, I'm down to 2 minutes now, and we were with Fleetwood Mac, and I asked Ernie to play Don't Stop. And the point being, don't stop doing pre-algebra even though this class is ending. You keep doing it through the summer until you take Math 70. Don't stop reviewing because, folks, if you don't review, you'll lose it so fast it'll be scary. So, Ernie, to the slide in music and have a